All right. Hello, good morning, good afternoon. Welcome again to another ConsenSys Cypherpunk Hackathon workshop. We are doing a From Commit to Kubernetes, did I say that right? With
so.
Evans Tucker this morning. And I'm Shay. I'll be the MC for this series. And I'm just going to go through a quick housekeeping around CrowdCast, which is the platform we're using right now. On the right-hand side is a chat area that will be active throughout, as you can see during the waiting room and now live. It is active, so feel free to chat there. If you have questions, you can put them there, but we'd also encourage you to add those questions to Ask a Question queue, which is the bottom there, that little link. If you type a question in the chat and you put a question mark before you hit enter, you'll notice a little orange button pops up and says, would you like to add this to the queue? So that makes it really easy and convenient for you to add questions there too. When you add the questions to the queue, then we'll know to take a break and pause to answer some of those questions throughout. We'll also leave time at the end of the workshop to do some more Q&A for any questions that might have popped up or that we missed. So please add those there. You can upvote those if you see some questions that you're also thinking, and that way we can prioritize the ones that Evans answers, but for the most part, we usually get to all the questions. There's also no polls today. That's okay. We really want to encourage a really interactive workshop today with Evans. So please feel free to, ask away on the chat. If you are interested in coming up and asking your question on screen, on stage with Evans, just let me know in the chat. Just wave or say, hey, I have a question I'd like to ask, and we'll bring you up on stage and you can interact with Evans that way. Last thing is there's a little green or big green button at the bottom that says see more workshops and sign up for the hackathon. So this is where you can see our Confluence page, which has all the details of this hackathon and the workshops, all the available workshops you can RSVP, as well as a sign-up form for actually participating in the hackathon. That's June 7th through the 11th. Really exciting, lots of great prizes. A lot of these workshops are inspiration, hopefully, for all of you to want to innovate and hack on some ideas during that week. So please sign up there and we'll follow up with you on next steps and how to get your team together. Okay, without further ado, I'll hand the mic over to Evans.
Hey, welcome to my presentation. My name is Evans Tucker. I have been passionate about getting code running, keeping code running efficiently on highly available systems for over 17 years. And sometimes I've actually been able to do that. I started in 2004. I'm not going to go into all the details, but I kind of saw, from hardware and networking, physically racking and stacking servers, all the way through virtualizing everything, then moving everything into cloud services, then Docker containerization. And now we're in kind of the Kubernetes age, and I'm looking forward to helping build the next epoch of decentralized computing where everything is running on, blockchains and IPFS. That'd be awesome. So I've got a fairly long talk. I think I gave myself like a couple minutes per slide, so I need to go real fast. Some of this content, if we don't get to it, we're just going to skip past it. So we'll try to be mindful of the time. My PreRamble.
And Evans, if you feel the need, as you're going through this, as happened before, if you feel the need for a part 2 and everybody else is excited for that, we can always arrange that. So just keep that in mind.
Okay. Yeah. Cool. I'll try to at least get through, what's supposed to be covered in this talk, which is from commit to Kubernetes. That being said, I have, I guess I wanted to kind of preface this talk with, this talk is opinionated based on my experience. I am human. I make many mistakes. I love the term dev oops. It kind of defines your career. If you're not breaking stuff, you're probably not doing your job. Ideally, we don't want to be breaking stuff though. So we do want to build highly available, redundant systems that are secure and compliant to all number of standards. So here's a kind of a bait and switch I did. So I know we're supposed to be talking about from commit to Kubernetes. So why are we talking about security and compliance? I'm not an expert in either of these. I consider myself an InfoSec enthusiast, and I've worked in banking and healthcare at Charles Schwab, at Athena Health, at a few other companies doing stuff in the legal realm. As I was creating the presentation, I wanted to make sure that I included security and compliance somewhere in it because that's a critical part of DevOps. And At first I had it at the end. I was just going to throw some links in there. Then I thought maybe I'll just, mention security and compliance in every slide. And then I decided, the InfoSec teams I've worked with in the past, they always get the short end of the stick. I decided to call it out right here at the beginning. Security and compliance are critical. Before you even write that first line of code, or maybe as you're writing that code, you need to be thinking about what are the security and compliance implications of this code. So I just wanted to go through a quick high level of some things that are really important in this space. These are some hand-wavy software design philosophies that I feel make a lot of sense and that have worked well for me over the years. Principle of least privilege, and all of these, I heavily use Wikipedia, so all of these are Wikipedia links. You can go and read more about the kind of where they came from and the details of the tenants here. But principle of least privilege is essentially, didn't mean to go back. Principle of least privilege is where we don't want to have any more privileges than we need to. Services should run as their own user, not as root. We as users should not have access to change things or access to see things that we're not supposed to see. This goes right into separation of duties, which is a really important compliance term, where essentially the super short version of that is we don't want to have one person that can make changes that make changes to the company that could potentially cause security problems or exfiltrate data. So everything should have at least two people working on it. Ideally, we're not there yet, but ideally, DevOps should have access to production infrastructure only. Developers should have access to code only, and maybe management or owners should have the keys to decrypt the secrets in the PII that those systems hold in some sort of really secure system. Right now, I think DevOps has probably more power than we ought to, and Dev does as well. But we're going to work to fix that. The KISS principle is just the keep it simple, stupid. Basically, just don't overcomplicate things, which goes right into also YAGMI and Gall's law. You aren't going to need it, meaning don't build features out until you actually need them, because what you think you need will always change. And Gall's law is a really simple, is a really elegant one that says a complex system that works is invariably found to have evolved from a simple system that works. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working simple system. I find these to be really accurate. Maybe it's confirmation bias, I don't know, but definitely keep these in mind when you're writing code. Particularly how that code is going to be used. And then I am not going to get a chance to go into much of this, but this is just more of a, peeking behind the curtain on what ops does. This is stuff that I've had to do for the last, couple of decades. We have to make sure that everything is, secure, compliant, backed up, encrypted. We have to make sure the access controls are in place, documentation is written so that we have proper, controls and auditing and all of this stuff. This is not something I don't think you can do a lot from a dev perspective, but just know that there's a lot of work being done to make production. What you can do as a developer or as a DevOps person, any of us, actually all of us, is start following some kind of simple tips on making, writing secure code and following secure practices on our own laptops, as well as, the applications we're building. So these are fantastic resources. I highly recommend that everyone at least kind of peruses the OWASP top 10. This thing basically has, these guys collect the, kind of top 10 most data breaches, what kind of category they're in, rank them, put them in here for you, and you can just go in and see like SQL injection, super big problem, at least in 2017. How to prevent it, and they all have a how to prevent section and a lot of details about what's going on with all these. So these are fantastic. If you're writing anything that uses SQL, read that one. If you're writing anything that uses XXC, use this. Read through the the various documentation there. Don't commit unencrypted secrets. We sometimes get a little bit lax in dev environments. We think, oh, it's just a dev API key or a dev password. We need to be really careful with that. We need to break that habit and make sure that it's as easy to commit secrets to code in an encrypted fashion as it is to commit unencrypted things. As we get used to that, we'll get better at that, and it will make that problem go away. And there's a few others here about don't share secrets via email or Slack. We have a password manager at ConsenSys. Whenever I'm sharing a password with someone, we should be sharing it via a link to that password in the password manager, not through Slack, not through, Once again, say KeyPass, not KeyPass. What's the one that we've used before? Key Vault? No, Keybase. Right. So many key things. Not through Keybase, not through Telegram. Just send them a link to the password manager and make them log in. If they don't have access to it, they should talk to IT and get that fixed. Yeah. More cybersecurity tips. A lot of the links I have are actually just links to basically DuckDuckGo or Google queries, because there's a lot of really simple ways to find the information you want if you just know the words, the search words to look for. Oh, one last thing on this slide too. Renovate. One of my predecessors, not predecessors, one of the previous DevOps guys here at ConsenSys started using Renovate. This is a fantastic tool that as a developer you can add to your repo, or at least rather you can talk to us. I guess we can add your repo to it. It automatically scans for dependencies and automatically creates MRs saying, hey, there's a new version of this package or there's a new version of this thing. It's a delightful tool. So definitely, if you're not aware of Renovate and if you're not sure if your repo is using it, reach out and let's get that set up. This one we're gonna mostly go past. So being compliant. Again, as a developer, there's not a whole lot you can do here, but it's something that we all need to be building a culture of at ConsenSys. The short version is processes need to be documented. Production changes should require more than one change to implement, more than one person to implement. All systems need to have an audit trail, and controls need to be in place to prevent accidental or malicious disruption of services and exfiltration of data. This one, it's really there's a lot of banking regulations that don't necessarily apply to us, but these apply to all of our partners that we're partnering with right now. There's a bunch of stuff in here. It's tons. And then that's just the banking regulations. There's also, the actual compliance, mostly, at least in the United States, mostly done by the AICPA. I'm not going to get their name right. There's an accounting group that comes up with lots of these compliance standards that we need to start holding ourselves to. So, all right, time check, 17 minutes. All right, let's go faster. So code, this is what we're here for, right? What happens, after you commit your code? First of all, we've got VCS platforms. ConsenSys is trying to move to GitHub as our default. Unfortunately, the Codify group has mostly been based in Europe, and they started off with GitLab. That's not unfortunate. The Codify group was mostly based in Europe. They chose GitLab, which I frankly prefer over GitHub, but we need to unify on something to make it easier to support all of us. So this talk is going to be talking about GitLab and GitLab CI, but GitHub is going to be the standard that we should be moving to, or the new default we should be picking. That being said, there's also a cool project called Radical, which is decentralized Git platform, I want to say. It's basically trying to be like Git is already a decentralized protocol, but Radical can hopefully add issue tracking and other stuff that will make it easier to use that. I'm really hoping to see that product mature. It's a cool product. This is a really important one. So again, before we actually get to that first commit, we have to talk about organizing our work and our code. For true continuous integration, delivery, and deployment, you really, the easiest way to do this is trunk-based development, very small iterative changes and feature toggling. Basically, this helps our, this is basically the best pattern for small, high-performing teams of developers who need to release code and features as efficiently as possible, which is basically all the teams at the Codify group, and I think actually most of the teams in ConsenSys in general. We have a lot of really small teams with probably less than 6 people in a lot of cases, and this is just one of the easiest ways to get work done. Essentially, you make small changes, use feature toggles. This talk right here, or not talk, this blog, writing, whatever, it's fantastic. It's by Martin Fowler. He does a lot of really good discussions on kind of software design and philosophy. I highly recommend everybody read this. This one I didn't go through in detail, but I believe, this Launch Darkly blog at the bottom actually does a pretty good job of summarizing it. And then to compare to GitHub Gitflow, again, this is just a link to a search, Gitflow and Trunk. Almost all the results you'll find are going to favor Trunk because it's just a really simple, really elegant way to get code, out there. Tagging, versioning, this is actually something I was just troubleshooting this morning. I don't want to go into this too much. Basically, we're using the latest tool that we're using right now is called Flux. We'll get into how it works in a little bit. Hopefully, if I have time, we'll skip past this. Tagging is great. If you're using Symver, fantastic. Don't use a V in your Symver. If you're not using Symver, we're going to be using something like this most likely, which is a deployment environment, git hash, and then a Unix timestamp for reasons, which we can get into later. And then this is also really critical. Don't start with a blank repo. We have so much awesome code at this company. We have thousands and thousands of repositories, and a few of those are actually boilerplates that you can just copy paste or fork or whatever. And then start off with some basic stuff, basic tooling in place that does like this, the basic CI pipeline we want, a package JSON that makes sense for npm projects, and etc. So I highly recommend check out these three. They're not perfect. They could probably use a lot of work. But if we work on these, then we all start from a slightly higher place every time. We're working on the shoulders of giants here. Also, just search for boilerplate or module in either of our main kind of repos, GitHub ConsenSys or GitLab ConsenSys. You'll find so much stuff. So if you think you're the first person to write a piece of code ever, that's awesome if you are, but I very rarely find that to be the case. We have too much access. Access levels around here are too damn high. This one is, well, so I recommend that we all audit ourselves and relinquish access that we don't use or need. I'm going to be the first to call myself a hypocrite on this. I liaise with IT, or lazily liaise. I'm lazily liaising with IT to help them do audits of our various Git platforms. So I probably have way more access than I need. I should only have access to codify stuff, and I should only have ownership access to codify stuff that's in the infrastructure folders, where it's actually the GitOps code that manages our infrastructure. And similarly, developers really should not have write access to everything under ConsenSys or everything under some massive group. You should have write access to the groups you're currently participating in, and that's it. GitLab has some specific kind of quirks on how to do that with what types of access you have, but we're gonna run out of time if I try to go into details of that. So maybe that's for later talk too. There are 10 kinds of repos in the world. That's a binary joke. Application repos and infrastructure repos. So GitOps is how we manage our infrastructure as code. The tools that we often see in a GitOps repo or an infrastructure repo is Terraform, Helm, Flux, Customize, and SOPs is currently how we're encrypting our secrets. You can read about all of them here. We've got great Terraform modules already here. We've got a generic app Helm chart, which gets the job done for almost everything NPM and Go based. And then we have Artifact Hub, which is where you can find Helm charts for every other thing out there. Any service, Redis, Postgres, Cassandra, whatever, any service you can think of, there's probably a Helm chart for it on Artifact Hub. It's easy, just like, Helm install the thing. It's super simple. Examples. So I was hoping to get into some examples, but I'm not going to get any examples of the GitOps one because that's not as relevant to the audience of this talk, I don't believe. These are some of our GitOps repos. Basically, we'll just go into one. This is an older one. Essentially, you're going to have Terraform, Helm. Helm is a tool that you use to kind of define how applications are configured in Kubernetes. So, for example, we have an application called Goldilocks. It has, an ingress that has these various things. It has some resources defined, and this doesn't even have any settings. It's not a good example, I suppose. But GitOps essentially defines in code, usually YAML, how every application is configured, its environment variables, its feature toggles, its how much memory CPU it needs, all of that stuff, how many replicas you want, whether it's 1 or 20 or some auto-scaling group of some sort. And we are currently moving towards a system where we have a tool called Flux, which actually watches these repos. And when it sees a change in the repo, it automatically applies it to our cluster. Would love to get into that more. We'll see if we can have time to do that. So other than code, the other important thing that we're dealing with is artifacts. We have lots of artifacts. I'd like to keep artifacts in IPFS. For NPM, we can use NPM. Docker images, we put them in Harbor. I threw IPFS in here a bunch of times. We're a decentralized company. We are trying to build the next generation decentralized internet. We should really be pushing the envelope and putting all of our content in IPFS. I don't really want to see stuff in S3 buckets, or if we can avoid it, if we can possibly put it in IPFS, we probably should, because that is the decentralized way. Oh yeah, and this is another sad thing I've run into in my past. I think this was a story from a friend. someone left a bunch of build artifacts that were critically important on some forgotten Mac Mini plugged in under someone's desk. Don't do that. Let's keep all of our artifacts out there, ideally decentralized, if not at least in some system that's backed up and audited. Containerization. So code is awesome. We don't run code. We run containers in our infrastructure. Everything has to be packaged up into a Docker file. Creating efficient Docker files is incredibly difficult. This is a generic one, kind of best practices on how to make efficient Docker images that actually, use Docker caching correctly so they're not too huge and secure and all that stuff. There's specific ones for Node. I'm not super familiar with Golang, but here's what appears to be a good document on making them for Golang. And then finally, we have a tool that we use right now called Scaffold. I'm not sure if this is going to stick around forever or not, but this is what we use to build our images. So you'll see like a scaffold.yaml file in your code repos that probably has some configuration on how to tag the image correctly so that our Flux image policies can pick it up correctly. All right, finally, halfway through the slides, and we're finally getting to that first commit. Yeah, and halfway through the talk time too, almost. So continuous integration and delivery and deployment. CICD really means continuous integration and delivery. The deployment part is something that we can really get to after we get really good QA and automated testing. The ideal, and again, in some utopian DevOps paradise, your code, you commit your code, it goes through all the tests. It does, all the unit testing, security testing, integration testing, all that stuff. What I put here, I put some funny stuff. Yeah, headless puppeteers waving cucumbers at our websites to make sure they're pixel perfect or something. I don't know much about that part of it. But you have all of that testing automated. And once you get all of it to automated and load testing, once you get all of it automated, you could theoretically push code directly to prod if it passes all tests, which would be fantastic. That is what we consider continuous deployment. And it's going to get really confusing here in a minute. But yeah, so we're going to focus on the first CI/CD, which is delivery, which basically means CI is continuous integration. Again, lots of Wikipedia links. This goes into kind of the general common practices of this. Use the code repo. You want to probably, again, do trunk-based development, commit to baseline every day, use feature flags to toggle out. If you're building a giant new branch of things, put like an if statement and a feature toggle in there somewhere that says, if new feature 1 equals enabled, then here's my feature. And just keep committing that code to branch, to the main branch, the default branch, as often as possible, so it's transparent to all the other developers, and so that it is, you never end up in merge hell, which is something we want to avoid. Continuous delivery. This slide has this is such a simple graph, but this is delightful to me. I want us to get all the way here, all the way. This last part here is the continuous deployment, this last little step. So basically what we want to be having is you check in your code to your version control system, Git. It fails build and unit tests. Okay, you fix it. It passes those, and it goes through the automated acceptance test. It fails those. Okay, you fix that. It passes this, and then you go to user acceptance testing. And if someone manually clicks a box somewhere like, yes, we tested everything, QA has signed off, this is in UAT, it looks good, and we want to ship it to prod, and then you have an approval and you ship it to prod. Ideally, we could theoretically get rid of these if we have enough testing. That's, again, kind of utopian. But these two steps, this process, this general flow is perfect. This is what we want to have everywhere, in my opinion. Test-driven development, I'm not the expert. I hope you guys are really good at this. I find it to be painful, I'm sure, having to write tests for things before you actually write the code for it, and then writing the code to pass the tests. It seems like you're doing everything in duplicate. However, if you do get good at this, we can actually finish that final automation and actually start shipping stuff directly to production if it just passes all the tests, which would be, again, a really cool ideal to aspire to. In the meantime, it would at least, prevent us from having to manually check stuff or having lots of regression bugs, which I do see fairly regularly here at ConsenSys. And then more pithy concepts. Release early, release often. Perfect is the enemy of the good. This is a personal one I have a lot of trouble with. I can be a perfectionist. It takes me forever to let go and just say, fuck it, ship it. And to that end, these are some 2 articles about kind of that whole process of just get an MVP out the door and then iterate some more and continue.
Yeah, Evans, that's a good point. I wanted to interject is that That is a common thing I think a lot of people struggle with is like it's so precious to them and they're always iterating and trying to make it more perfect before it goes out. What do you think is the best? I mean, I know a lot of these articles can recommend, but what, in your opinion, in terms of what do you think is a good MVP state where you should just let it go? And then from there you can, because a lot of times you do want to test and get some feedback in that stage because you can over perfect and maybe you get down the road a little too far without the user feedback, then this makes you a little bit more agile. What would you recommend?
Yeah, so I mean, essentially, as soon as it does something, as soon as it does a thing, and a user could potentially be excited about it doing a thing, you need to get it in front of the user's eyes and start collecting feedback. The users need to be in that feedback loop as much as possible. It should be like write code, test code, ship code, users talk about code, comments, and that should be the whole loop, right? So I would say as soon as the code can, I don't know, what's a good one? Like, let's use Metaswap as an example. I don't know if they did this. I wasn't following their development super closely. But if I were making a tool like Metaswap, which is a fantastic tool, as soon as it can do one swap, as soon as there's like, hey, we can do a swap, done, fantastic. Yeah. Then ship it. And then add more swaps, add more tokens, add more dexes, and continue iterating on that. Add more UI, add more, user, UX stuff and UI stuff to make it a more pleasant experience. Add it to the mobile side. So the first thing that they needed to do was just like, swap something, and that's it.
Right. I was going to say, so that was when you're saying pick a thing, that would probably be the thing. What was your main kind of feature of building this in the first place? The main thing you were trying to solve, and that would be your MVP, right? As long as you can get it to swap. Yeah. Does it look great? Is the interface of how that happens great? Yeah. But just make sure that can work. And then, I mean, a lot of times people want to take it a little further so it's easy to engage with so you can get that feedback. Yeah, but I think to your point, right? The main feature, don't have all the special nice to haves. The must have, right? The must haves.
Yeah, get the must-have feature out there, get it in front of users, and get some feedback. Because if you don't get that feedback early, we're going to fall into like kind of the Gall's Law thing again. If you build this really complex, super cool system, but you forgot to actually like iterate on that and get user feedback, you're going to have this really complex tool that no one cares about using,
Right. You spend all this time building it, right?
Yeah. This goes into. Yeah, go ahead.
No, you go ahead.
I was going to say this goes into a core thing for DevOps, the DevOps side of things. I am a super huge fan of the CNCF. It's the Cloud Native Computing Foundation. I tried not to write code as much as possible. I try not to customize things as much as possible. I try to use whatever is most popular with the open source community at the time, because that community support is critical in DevOps. So like this Flux v2 thing, I'm a little suspicious of too, because like right now there's Flux v2 versus Argo CD. Which one's going to come out on top? They're both CNCF products now, or CNCF sponsored. So, we have to in DevOps we have to constantly be watching that and migrate to the tool that has the community. Because if we don't, we're going to get left behind and be using some thing that's very difficult to support and write a bunch of custom code. Anyway.
Absolutely. Actually, Evans, great answer. We do have a question. This is coming from Amal. Thank you, Amal. Does perfect is the enemy of good, and F it, ship it, or I like to say JFDI, just effing do it, makes sense in a system where we're creating platforms that manages value? For example, getting it wrong or having it low.
I actually thought about that as I was writing this.
And then he said standard could lead to a situation that wipes out a user financially. How does one upgrade dApps contracts at our current maturity level? Good question.
Yeah, thank you very much for slowing me down to answer that. I was thinking about this when I said this, because there is a balance, right? This goes back to why I interjected security and compliance at the beginning. If your basic MVP product is like, I want to hold your balance and do some DeFi thing with it, then your basic MVP of that needs to be secure and compliant. Oh man, I didn't read the funny part I had in there. But if we're not watching, I'll try to paraphrase it. But basically, if we're not thinking about security and compliance when we're designing code, nothing will save us. All we're going to be doing is building really awesome UX with 99.9% uptime that's totally exploitable and illegal, and that's not helpful. I don't need to build like exploitable illegal systems that are super resilient. We need to build secure and compliant systems first. So I would say
have a good foundation, right?
Yeah,
exactly.
Yeah, this is that whole foundation thing. Like we do need to get stuff out the door, which is where this comes in. But we also need to part of that MVP needs to be security and compliance, and we have to build security and compliance as a core tenet of our culture and our structure, especially because we are who we are. Not only are we in the finance industry, which is going to has a ton of regulation, a ton of oversight. But we are also in the decentralized finance industry, which, despite the regulation and oversight, cannot be stopped. This is code that literally cannot be stopped unless you shut down the whole network, which I don't know how you would go about shutting down Ethereum right now, other than a Carrington event. Read about that later if you want to have nightmares. Anyway, so yeah, I would say that's part of the MVP is my answer essentially. For financial products, for things with real value, for medical equipment, for life-saving devices, this still needs to be the philosophy you follow, but obviously part of that MVP is it has to work 100% of the time, or it has to be, you have to have a backup plan for if you lose funds or if, a medical device stops working, and someone's heart stops beating. You have to have a backup plan. Backup plan for sure. And that goes right back to that first slide about security and compliance.
All right. Thank you, Evans.
Yeah. What time are we at now? 35. All right, we're good. So we use GitLab CI. These are all chock full of so much good information. These are amazing. Pipeline architectures, runners. This is kind of how CI/CD works. This is how you build pipelines. I'm not going to spend time going through this right now because I'm going to try to save it for going through an example pipeline so you can see what happens when your code gets committed rather than explaining how the pipelines work. But the short version is all the CI stuff is YAML. It basically is a bunch of stages and jobs. So you'll have some stages like compile, test, and deploy. You'll have jobs in those stages. Oh, actually, we're getting this in the next slide, I think. But we'll get to that in just a moment. The pipeline architectures, there's all kinds of stuff you can do here as far as like putting stuff, strictly, this job runs after this job, which runs after this job, or putting like a DAG pipeline, a decentralized acyclic graph pipeline, I think, where the jobs, this one needs the build artifact to exist, and this one needs something else. They can kind of just follow their dependencies, and they can start building in parallel. We want our pipelines to be super fast, so we probably want to do as much possible work as we can to optimize all of this. And then we actually have a really good, so this is one thing that I'm hoping we can do well if and when we move to GitLab. I think we might be moving to GitHub Actions, possibly. I'm not sure if that's been totally decided or not. But if we do, this GitLab templates repo that we have at Codify is getting pretty mature right now, medium mature. It has a lot of really good stuff in it already, which we will go to in here. So lots of the stuff that our pipeline does. The first thing you need to do, we're going to talk mostly about NPM packages or NPM applications right now, just because that's mostly what I'm working with right now. We do an NPM or a yarn install. There's in the compile stage, there's usually jobs that do this stuff. There's something to do linting and prettying your code, auditing dependencies. I just want to underline this a few more times. Again, I think we have a stage right now called audit, and if it fails, it doesn't fail hard. It doesn't stop the job from running. It's as simple as running npm audit fix to fix a lot of our security problems. We need to be running that all the time. In fact, I would love to automatically run jobs on all of our active code repos and just do an npm audit fix every week, just to see, just to get that stuff cleaned up, make sure we're staying secure. After that, there's a testing stage. Usually in a testing stage, you're going to see some jobs like code coverage, integration, unit tests, etc. Code quality via SonarQube. I'm going to apologize in advance. Our SonarQube is badly, I think the access is messed up to it, so I don't think anyone can actually get into it right now. So I wish I could demo this, but I cannot. And then container security. This one's also got a funny bug. We have a tool called Trivy made by Aqua Security, which scans Docker images for CVEs, for any kind of known vulnerabilities. It's fantastic. Our Harbor Docker image repository, container repository, is so awesome that it will not serve images that have critical vulnerabilities. So the funny thing that happens here is if you build an image that has a critical vulnerability, it puts it in Harbor, then Trivy pulls it from Harbor and tries to scan it, but Harbor won't serve it if it's got a critical vulnerability. So if your Trivy Docker security thing just fails to pull the image, that probably means it has a critical vulnerability, which is unhelpful because you can't see what the vulnerability is, because Harbor is also not a tool that everyone can log into right now. We'll get it fixed later. Yeah, here we go. So if everything looks good, we usually do a deploy stage, which confusingly is part of the continuous delivery concept.
Evan, sorry to interrupt. On that past slide, when you recommended the tool, was it Docker or was it the other one you just mentioned?
Harbor is a Docker image repository. So
gotcha.
Harbor is where we store all of our Docker images. We could go into some stuff about this. There's a million image repositories. There's Amazon ECR, which is there where you store images on Amazon typically. There is GitLab has a built-in one, which is not great because if you remove the repo, the images get all wiped out, which is horrible.
Right.
And then Harbor.
Links.
Yeah, exactly. And Harbor is one where we actually run it in our cluster, and the purpose for this is I want to be control of my images. This goes back to the decentralization thing. If we rely, or rather, this goes back into kind of dependencies, right? If we rely on ECR or GitLab for our images, and then if that is not available, then that can impact our service. And I want to have as few things that can impact our uptime as possible. So putting a Harbor repo in our putting a Harbor repo registry. Let me slow down. Putting a Harbor registry in our Kubernetes cluster makes it close, so it's right there. It's like in our network, so everything can always pull its images. It makes it secure because we're not sending our images all over the internet, and it makes it something that we can control. So if Harbor goes down, I can fix it. If ECR goes down, I have to sit and wait for Amazon to fix it.
Okay, I see why you're recommending that. Okay, great.
Yeah. But yeah, that's a personal. I would say I think I'm known at this point for having a strong preference for free open source software and self-hosting. I don't want to do it so much that it's my entire job, but I do think for critical components like images, that's a good idea. Yeah, so this whole deployer delivery thing is confusing. This is me trying to be funny about that. But basically, in the deployment stage of a typical CI/CD pipeline, you usually have some kind of job that either does a canary release. We would love to get blue-green deployments. We don't have those yet. Right now, most of our deployments are basically these hacky deploy.sh scripts, which literally just use an SSH key to log into the GitOps, like the infrastructure repo, and change the image tag there, and then push it. And then that triggers another pipeline for that. This is an anti-pattern at this point. This was something I did because I didn't know how to do any other things. This Flux v2 thing came out recently. We're actually early adopters of this, I would say, and it does a much better job of it watches Harbor basically, and if it sees a new image in Harbor, it looks at its image policy, and if the image policy says go ahead and use that image, then it actually checks out the code, makes a git commit in the infrastructure repo, and then it watches the repo also, because that's what Flux does, and it makes whatever happens in the repo happen in the cluster. It's a little bit convoluted, but it's a much more secure way of doing it, because the previous way with this basically gives the developers potential access to do things that they should not be able to do. This deploy SH script has way more power than it ought to, so we're trying to get rid of all those. Examples. All right, this I want to take a little bit of time. Oh man, we're running short though. Let's just skip right to our latest and greatest example. So we have a new project we've been working on. This is a pipeline for it, an example pipeline. Let's see if they've, yeah, good, it's nice and long. Okay, so when you commit your code, typically people do an MR. Let's actually start with that. I'll actually stop doing that so it stops blinking away. When you do an MR, this is a good MR pipeline. Well, it's a failed one. Let's find a successful one. Here we go. So we have a bunch of stuff in here, and this is the beauty of CI/CD. You can bolt on as many little weird things as you want. We had a problem where a lot of our stuff was set as like an MIT license. This is not MIT licensed software. This is custom private software that we're writing. It needs to be unlicensed. So this thing just checks your licensing. This compile does like an npm install or yarn install, I believe, right here. Kind of builds everything up, throws it in the cache. We have formatting and linting, prettying. Again, these are jobs. I'm not sure if I like how these are set up super great, because they basically just call like an npm run lint. So you as the developer still define what that run lint does, which is fine, but we should have some good boilerplate to make sure it's actually running. You can just make this say true, or just to be a null thing, and it'll just pass. Ideally, we should do a little bit better job there. Prettier makes your code prettier, I guess. I'm not super familiar with it. Audit. This is the important one that I care about a lot. Oftentimes we'll see this. Again, this is just, I think it just runs. Well, this is like a real command, yeah. This one's really important, and if you see stuff here, ideally in the near future, I'm going to make this job actually break the pipeline when it fails, because we need to stop, releasing things that have known CVEs, known vulnerabilities in them. So that's a critical one from a DevOps perspective. Then we've got unit testing and some other stuff. Nope, that's not what I wanted. The build, this is the thing that runs the scaffold, which builds the image. Basically just a Docker build. It tries to do some intelligent stuff with caching to make sure it pulls a cached image from our harbor so it doesn't start from scratch every time. And then it tags it using a tag that our Flux v2 image reflector can read and knows is a new tag. We've got some integration testing. So this is a great thing that I think the assets team has done a great job with this. As far as like using ephemeral environments a lot. I don't know if this is actually the same thing, or maybe that's the next one over. We often have a pattern where we use an ephemeral environment. So we'll spin up a namespace in one of our multi-tenant kind of shared Kubernetes clusters. It will have all the things that you're about to test together in that namespace, and it will run an integration test on them. And then it will tear down that ephemeral environment using this tear down job. So basically just creates your stuff in a brand new kind of pristine state, runs the tests, and then destroys them. And then this is another cool feature of GitLab CI is that you can actually target or trigger upstream, not upstream, you can trigger other pipelines in other places. So this one, I'm getting out of my comfort zone because I'm not super familiar with this, but this is I think this is another ephemeral kind of test where it does something probably very useful. So that is an example of a pipeline for an application repo. Let's go into a GitOps or an infra repo real quick and show you how that works. This one, this is the kind of the latest iteration of our architecture. This is what the target state is currently. There's actually not a pipeline. There is no GitLab CI YAML. The way this thing works, there actually could be if there was Terraform, but there's not any Terraform in this particular repo. The way this works is this uses Flux, which again is a CD tool that essentially watches a repository. If it sees changes, it applies that repository to your cluster directly. So it's just constantly watching this thing. If we make a change in here to some YAML file, say the back end, we decide we want to add an environment variable. So we add another environment variable here. Once we commit that code, within about, I don't know, a minute or 5 minutes, I forget the timing we have, Flux will see that, will attempt to apply that, and if it fails to apply it correctly because there's a typo or something else weird going on, it'll spit out an error message in the Flux logs, which we also need to be watching more closely, but we'll get there. This is a really good pattern for GitOps and for DevOps because everything is auditable. Every time someone makes a change here, I can see what changed, who changed it, when it changed. So this makes it very easy to troubleshoot. Are we having an issue? First thing you do, come over here, check, and look for any commits. Did something break an hour ago? It may have been this. So this is a really useful thing for DevOps. That it also keeps our architecture. I have a good slide. Hold on. I think I had a good blurb about this somewhere. Oh, it's in the GitOps. I think I have a GitOps slide in the moment. So anyway, yeah, this is a really good pattern for us. The pipelines, you can continue adding more and more jobs, more and more tests, more and more random things. It can do anything you can script or write code for, you can do in your pipeline. I don't think have a good example of, like I said, kind of user interface testing yet. I think there's a few people using Puppeteer. I would love to see that spread out across all the Codify projects and all the ConsenSys projects. We should be doing all of that stuff in pipelines. Oh boy, 12 minutes left. Kubernetes, everything you ever want to know about Kubernetes in 12 minutes.
You got this.
Yeah, I got it. It's all good. Yeah, so we want to run a tight ship or the bicycle here at ConsenSys. This is what I consider good FinOps. This is a new term I discovered recently. FinOps being finance and ops working together. This is very efficient. Good value engineering is another term I heard recently. This is fantastic. So our Kubernetes clusters are running really tight. Our Codify devs sometimes don't like that because occasionally jobs fail and you have to retry things and it sucks. It's not a great developer experience, which I'm working to fix. Yeah, what does it say? Needs 12 hours. Yeah, no, I can do it 12 minutes. Here we go. Yeah, the quality's all downhill from here too. Concepts, just read this on your own, but I'm going to go into the ones that are important for this talk today. So what is Kubernetes? Running a Docker container on your laptop is great. If your laptop blows up or gets stolen, it's not great for that service that was running. So if you had like 5 laptops or 5 servers and you wanted to run Docker on them, you have to have a tool that can coordinate. I only need one instance of this thing running at a time. So it has to talk to all 5 of your nodes and it has to run only one instance of that across all those. So that's Kubernetes. It's a container orchestration system, super high level. Everything in Kubernetes is an object, a YAML object. So if you have a keen eye for spotting errant, white spaces, in your code, then you'll be great at DevOps. If you don't, you're going to spend hours and hours and hours troubleshooting something that was indented not quite the right amount. So I love YAML and hate YAML at the same time. It's very easy to read, but sometimes those errors are difficult to catch. Kubernetes has nodes. That's the term they use for a compute instance. That's the term they use for a server or a compute instance or a laptop or whatever is the actual hardware or virtual hardware running the compute and the memory is called a node. It also has namespaces within a cluster. You can have, we'll just say basically like folders for all of your different types of things. So I could have we have a multi-tenant cluster, some older clusters that are multi-tenant, meaning we have like dev environments, 12 different dev environments in one cluster, and they're all just in their own namespace. So, activate dev and airswap dev and blah, blah, blah. Workloads, we're actually going to click on a link here. So workloads are the different types of ways that you can tell things to run in Kubernetes. Deployments and replica sets are basically for your standard issue. I need a service and it needs to run 1 instance or 3 instances or 100 instances. A stateful set is typically something like a database where you need to have storage attached to it, and it has to run with a particular volume attached to it at any given moment. And then daemon sets are things like FileBeat, other things that collect logs and metrics that run on every single node. If you define the daemon set for FileBeat, it runs on every node in your cluster. And then there's also jobs and cron jobs. We have a few of those used, not too many. Yeah. Oh, and then pods is kind of the smallest, what they consider as the smallest. It's just like the atom, I guess, was the smallest unit in the physical world for a while. And then we discovered subatomic particles. Pods are what are to the atom in that way. It's the smallest unit that Kubernetes cares about, but really pods can have multiple containers inside of them too. We're not going to get into it. Basically, when we say we want to restart something in Kubernetes, all we're doing is deleting a pod, and then the deployment that created that pod will see is, oh, hey, I'm missing a pod. I'll create a new one. So that's how you restart stuff in Kubernetes. You delete pods typically. And then here's how here's how your services work together and how the world works with your services. We have an object in Kubernetes called a service, which basically points to usually a replica set or a set of endpoints. So if you have a service for Redis, and that Redis on the other on the back end has like a deployment of like 3 different pods, that service points to any of those 3 different pods basically. There's kind of local DNS inside of Kubernetes. So if I had a service called backend API, I could just go to backend API in my environment variables for the other services in that namespace. If it's in another namespace, we get quirkier, but anyway, that's the short version of that. Lots of local DNS. Ingress and ingress controllers is how the outside world gets to your cluster. This part's a little bit trickier. There's a lot of different ways to deploy clusters. And again, moving into a more ideal world, I would love to have clusters in a private network where we have a load balancer that's the only thing that's exposed to the internet. Right now, our load balancers, our clusters are typically set up not in a private way. So we have, you go to activate.codified network, that goes to Cloudflare. Cloudflare redirects it back to an AWS NLB load balancer, network load balancer. That load balancer then points to a Kubernetes ingress, and that ingress that load balancer points to all of your Kubernetes nodes, and the Kubernetes nodes that have that running service on them have an ingress. I might be explaining this wrong. We're not going to get into the weeds here, but ingresses are how you get traffic from the outside world into your cluster. There's a lot of cool stuff. We often use the Nginx ingress because it's the most mature kind of default one, and frankly, I love it because it has so many annotations. You can do everything with this thing. You can put in basic auth. You can put in, canary. Wow, I should look into this. I don't know how the canary thing works. You can put in like rate limiting, web application firewalls, global like blocking things, proxy stuff. It has annotations for every damn thing you can think of. It does all kinds, mod security stuff, all kinds of cool stuff. It's delightful ingress controller. Storage secrets, etc. So this gets into some more, I'm not going to get into it, but basically some people don't like putting storage in Kubernetes clusters. I think it's fine. It works great. I've been doing it for years. I run databases in Kubernetes. I run Redis clusters in Kubernetes. I've run a Cassandra cluster in Kubernetes. That was terrible because I'm an awful Cassandra admin, but that was on me, not on Kubernetes. Storage is usually just backed in Amazon via their EBS, like with their Elastic Block Storage, which is basically a storage area network inside the Amazon cloud. So it's super fast. We actually have a problem with one of our other clusters in Azure where they have another type of storage called EFS, or in Azure it's called WFFS or something, I forget. It's basically their NFS or CIFS kind of thing, like a Windows file share or a NFS kind of share. Don't use those unless you really absolutely have to. They're very slow, they're buggy, they're miserable. Secrets, secrets in Kubernetes. Kubernetes secrets are base 64 encoded. Which is not encryption. They're all basically in clear text. If you have access as a user in Kubernetes, if you're RBAC, if your role-based access control grants you access to read a secret, you can see the secret. It's not encrypted. It's not secret. We put all of our secrets in code encrypted in SOPs, which is, I'm not going to get into how that works. I got documentation for that. What are we at here? Like 5 minutes? Dang. Okay. Anyway. Secrets is a problem. Security issues, we got to work on that and do it better. I mean, we're doing the best we can, but Kubernetes kind of by default is the secret management is kind of crap. Resources for containers. This is another big contentious topic, which I could probably do 15 minutes on at least. Going into like cluster autoscaler versus horizontal pod autoscaler, vertical pod autoscaler. This is basically, you have to tell your workloads how much space they'll need in your cluster. Otherwise, your cluster doesn't know how much space to give them. So it'll try to spin up a thing that needs like 2 CPUs and 8 gigs of RAM on a node that only has like 1 CPU and 5 gigs of RAM left. And then bad things happen. So you have to manage your resources really well if you want Kubernetes to do a good job managing all of your workloads. We're in the process of getting better at this. We don't have, anyway, again, that could be a whole other talk. Kubeconfig is basically how you access a Kubernetes cluster. I was going to put some information in this talk about connecting to clusters and all that, but frankly, reach out if you're curious. And then security, yeah, I feel obligated to click on this and at least show it. Shay, I saw you popped up for a sec.
Oh, no, yeah, continue. Actually, go ahead and, what did you want to I guess, glean out of this, wanted to mention out of this in particular?
Well, this is a bigger topic too, which we don't have time to get into, but there's a lot of cool stuff for, RBAC is the main thing. I'm not even sure if this mentions it, but there's also like OPA, which is policies for Kubernetes. There's a lot of stuff in Kubernetes security that we need to be doing better. As a developer, most of it is not super critical. I think we're just going to skip this section and call it a day. So yeah, Kubernetes in 12 minutes, best I can do. I had a whole section here, but frankly, you're not missing out. There's no good slides here. But after your code is actually running, there's a whole other thing of, there's a whole lot more that we can still do. So, yeah.
So observability and monitoring, that last section that you were saying is a whole, but that basically is like you said, once you have that set up, and these were recommendations of how best to do that. The monitoring stage, basically, like keeping an eye on it.
Yeah. I mean, we'll just skip that whole section because there's, again, that could be a whole nother talk. But the short version is once your code is up and running, if you're not watching it, if you're not monitoring it, if you're not measuring it, anything could happen.
Kubernetes you gotta keep an eye on it.
Yeah, you got to keep an eye on it. It's like a young child.
Right. So
you leave them alone in the room for like 10 minutes. All of a sudden, they've put a hole in the wall.
Right, you can't forget. So no, that's good advice, actually. Even though you can't deep dive, but it is good to know. Like once you spend all that time and all that hard work, you do have to keep an eye on it at first. Like make sure things are working as they should, especially in that kind of first wave of release, right? And then you could start to get the sense of how things are. And I guess more and more as you do more projects, does that get more kind of automated in your process, or do you think it's each new one is its own little unique baby that you got to take care of? This
goes back to the boilerplate thing. There's a lot of default stuff in like Grafana and Prometheus and Alert Manager that does all the things that we want on a basic level. It'll tell you if your service is still running or not, which is important to know. If you want to get into really detailed graphs, the staking team has done a fantastic job. They have a really great Grafana dashboard showing like all these statistics about exactly how Teku's working and the number of attestations and all this stuff. It's fantastic. You have to build that. But when someone builds that, if we build, things like if someone could build a good one for just NPM job monitoring, or like I know previous company Java, you have like a JMX, hooked in, and you're like using your kit to like review all your Java statistics, putting that all in a chart somewhere. Once you get those charts up and everyone starts using them, it makes everything better across the board for like all the teams. So we need to do a lot of work for that at ConsenSys, I think, to get better observability. It's harder to, this sounds really
tracking,
dumb and old school, but like it's harder to do observability when you don't have like that like network operations center with like the 12 giant monitors with all the graphs. You can just like, oh, I see a spike over there. What's causing that spike?
Right.
You can like see what's going on with your cluster. I can't do that with just 2 screens.
Yeah, it's literally like in a hospital, like when you have all the kind of medical monitors and you're kind of keeping track of all the different systems.
Yeah.
Absolutely. So can you move it to the very last slide there if you have a chance, Evans?
Sure.
Thank you so much. I know you felt rushed, but hey, if everybody's interested, and we can take a pulse on Slack as well. If everybody, if we see interest in people saying, yeah, I would love a deep dive or a part 2, then maybe we can engage you to do that as well. Evans, does that work for you? If there's enough interest?
Yeah. Honestly,
okay,
I think you asked me at the beginning whether I should do 1 hour or 2, and I think I said 1 should be plenty. But now I'm having regrets.
Yeah, the 90-minute slot. Well, hey,
although I don't know if the interest of the group would have been for 2 hours of me ranting about this stuff.
No, I think you'll probably have some interest. So we'll ping you online, and anybody who is currently still on, let us know if you'd like us to do a part 2 for this particular topic, and we'll also hit you up on Slack. And to remind everybody, please join us on ConsenSys Hackathon 2021 Slack channel. That's where we can we'll be posting all the slides, all the different links to the workshops that you can RSVP. Links to sign up to participate in the hackathon, all the details around this series and this event. Yes, and of course I don't know if you read the little note, but all these workshops are available for pretty much immediate playback, replay, at the very exact same link. So it makes it really easy. So probably 5 minutes after we end this airing, you'll be able to replay this. And we'll also post this on the Slack channel too. But thank you again, Evans. We really appreciate it. I know there's a lot of great content. I know you were trying to figure out the key points.
I could do so much more.
No, of course,
anyway.
But hey, and maybe there'll be a part 2.
Yeah.
So hopefully everybody will join us for the next workshop. Thank you again for showing up today, and thank you again, Evans, for a great workshop.
Yeah, thank you very much for giving me the time.
You got it. All right.
See you guys around.
Okay, bye-bye.